Today, let's talk about how to expand logarithmic expressions. So, let's start with this first problem, which would be log of x multiplied by y multiplied by z, or log xyz basically. So, in order to expand this, we must be aware of the three properties. Know that log AB is equal to log A plus log B. Log of A divided by B would be equal to log of A minus log of B. Whichever has the negative term here would be on the denominator. And lastly, know that log of x to the power of c would be equal to c multiplied by log of x. Basically, you can put down c as a term. So, for this one, it would be the expanded form would be log of x plus log of y plus log of z. Next up would be log of x squared multiplied by y squared multiplied by z. Next up would be log of x squared multiplied by y squared multiplied by z to the power of 4. And so, since this is all multiplication, it would be all addition again. So, this would be log x squared plus log y squared plus log of z to the power of 4. And so, since we have an exponent right here, the final answer here would be, for this property, log x to the power of c, you can put down the exponent. So this would be 2 log of x plus 2 log of y plus, since this is 4, so this would be 4 log of z. Log of x z squared divided by y. And so, when encountering a problem like this, the first thing you're going to do is to focus on the numerator. Since this is x multiplied by z, so this would be log of x plus log of z squared. And so, focus on the denominator then. It is y. So, this would be minus log of y. Or if you can rewrite this, if you want, this would be minus log of y plus log of z squared. The order really doesn't matter here. And so, in order to have a final answer here, you must check whether they have an exponent right here. So, we have a2 here as an exponent, so you can bring that down. And so, your final answer would be log of x plus log of y. This is, minus log of y plus 2 log of z. Log of xy divided by z, all raised to the power of 2. And so whenever you encounter a problem like this, you can either put this as log of x squared y squared divided by z squared. But if you want to simplify, you can think of this as a singular variable raised to the power of 2. And so you can actually put 2 here. And so this would be 2 log of xy divided by z. And so, by expanding this expression, this would be 2 log of x plus 2 log of y. And since this is a denominator, this would be minus 2 log of z. And if you do it upon this way, so this would be log of x squared plus log of y squared minus log of z squared. And so you can, since they have an exponent right here, bring this down. And so this would be 2 log x plus 2 log y minus 2 log z, which is the same as this. Log of y multiplied by the square root of x, all divided by z to the power of 3. So whenever you encounter something like a square root here, the best thing here would be to put this into their exponential form first. Know that square root of x is the same as x to the power of 1/2. A cube root of x is the same as x to the power of 1/3. And so by this we have a square root. So we can rewrite this as log of y multiplied by x to the power of 1/2 over z to the power of 3. And so we can expand this normally. So this would be log y plus log of x to the power of 1/2 minus log of z to the power of 3. And so since we have an exponent here, we must bring them down. And so your final answer would be log of y plus 1/2 log of x minus 3 log of z. Next up would be log of x plus y all raised to the power of 2 divided by z. Now whenever you encounter a problem that has a parenthesis here, know that you shall treat this as a singular variable only. Don't split this apart or expand this expression. So just think of this as a or b or something. And so by the quotient rule, this would be log of x plus y squared minus log of z. And so since we have an exponent here, we must bring them down. And so your final answer would be 2 log of x plus y minus log of z. And so that's how important having a parenthesis is in an equation. Having a similar problem to the last, log of z multiplied by x plus 1 raised to the power of 3. And so this would be one variable and this would be another variable. And so since they are multiplied, it would be addition. So this would be log of z plus log of x plus 1 to the power of 3. And so bringing down the exponent, your final answer would be log of z plus 3 log of x plus 1. Log of a multiplied by x squared. So this would be simply log of a plus log of x squared. And so bringing down the exponent, this would be log a plus 2 log of x. Log of x squared multiplied by square root of 9 over z. And so we can rewrite this first. This would be log of x squared multiplied by, know that whenever you have a square root here and it is inside a fraction, you can rewrite this as square root of y over square root of z. And so this would be simply log of x squared multiplied by square root of y over z, since you just multiplied that. And so the last step would be to convert this into their exponential form first. So this would be log of x squared multiplied by y to the power of 1/2 over z to the power of 1/2. I forgot this should be square root of z. And so this would be log of x squared plus log of y to the power of 1/2 minus log of z to the power of 1/2. And so your final answer would be 2 log of x plus 1/2 log of y minus 1/2 log of z. For the last problem, log of 1 over ax squared. And so this would be log of 1 minus log of a minus log of x squared. Or if you want, this can be also a solution. Log of 1 minus log of a plus log of x squared. Since you know they are multiplied to each other, so you can put this as plus, but since they are on the denominator, it would be minus, which brings you to the same answer, log of 1 minus log of a minus log of x squared, which is this. And so your final answer here would be log of 1 if you want minus log of a minus 2 log of x.